My dears, today in this class we are going to learn about one of the important chapter from class 10, that is atomic structure. In this atomic structure chapter, we categorize into three parts. In the first part, we need to learn about electromagnetic radiation and characteristic properties of electromagnetic radiation and wave properties, spectrum and types of spectrum. First we need to discussing electromagnetic radiation. Here, what is electromagnetic radiation? Simple definition and meaning: the radiation which is a combination of the radiation which is the combination of the radiation which is the combination of both electric field and magnetic field, both electric field and magnetic field, perpendicular to each other, perpendicular to each other, and also perpendicular to direction of propagation of wave, perpendicular to direction of propagation of wave. So it is the definition as well as one of the prime character of the electromagnetic radiation. Second point, electromagnetic radiation, simply abbreviated as EMR. EMR, no need to require any medium to propagate or travel in the space or vacuum. Clear? This point is very important. So electromagnetic radiation, no need to require any medium to travel in the space. For example, sunlight, they reach toward earth surface without any medium. The sun rays reach to earth surface without any medium. So here sun rays also one kind of electromagnetic radiation. They no need to require any medium to travel in the space. Similarly, as you know, the remote we use it to operate the televisions. When we press the button on the remote, it operates the target areas television. How it is possible without any cord or wire? That means when we press the button, there is a IR radiation. IR radiation is one kind of electromagnetic radiation come and release from the remote, and it operates the target areas. Here IR radiation is one kind of electromagnetic radiation. Even sunlight also one kind of electromagnetic radiation. So that these are the radiation, no need to require any medium to travel in the space. Now coming to the third point, very important point. Different electromagnetic radiations have different wavelengths. Different electromagnetic radiations have different properties. That means different wavelength are different frequencies. Different frequencies. Different frequencies, but they have same velocity. They have travel with same velocity. Same velocity, that is velocity of light 3 into 10 power 8 meter per second. You know, this is very important character of electromagnetic radiation. The speed of electromagnetic radiation, the speed of EMR, electromagnetic radiation, we can't imagine because it travels per second. There is a nearly about 3 lakhs kilometer distance travel per 1 second time. So that this is the speed we can't imagine, right? It is one of the most advantage character of electromagnetic radiation. Because of this character and high speed character, now we can develop the telecommunication system, radar communication system, satellite communication system. Suppose you can ring a mobile number of your friend or colleague or relative from your sitting place. They can receive your call from far away from you within the fraction of seconds. How it is possible means because of that electromagnetic radiation has a high speed. Within the fraction of seconds it travels a long distances. So around it is 3 lakhs kilometer per second. Because of this high speed character, we can enjoy the telecommunication system. Even some program, television program, they broadcast somewhere, Delhi or some other places, we can enjoy within the fraction of seconds in our sitting places on television. How it is possible is because of high speed character of electromagnetic radiation. I hope you all understand, right? This is one of the most important feature of electromagnetic radiation. Okay. Now coming to the next characteristics of wave. Our next concept is characteristic properties of wave. Now coming to the characteristic properties of wave. The wave is characterized by certain properties. One of the important properties, wavelength. What is wavelength? The distance between the corresponding points of a wave. That means here corresponding height of the wave is nothing but crest. Here depth of the wave is nothing but what? Thrift. The distance between two successive crests or two successive, that means side by side thrift, are called wavelength. This wavelength we can denoted by lambda. The wavelength denoted by Greek letter lambda. Okay. Now lambda or wavelength is equal to velocity by frequency. This is the relation among the wavelength and velocity and frequency. This simply mathematically we express lambda is equal to c by nu. Now coming to the units of wavelength. Units of wavelength. Here units of wavelength we can express centimeter, meter, nanometer, and angstrom and picometer. Most appropriate unit nanometer, angstrom and picometer. 1 nanometer is equal to 10 power minus 7 centimeter, that equal 10 power minus 9 meters. Here 1 angstrom is equal to 10 power minus 8 centimeter or 10 power minus 10 meters. 1 picometer is equal to 10 power minus 10 centimeter or 10 power minus 12 meters. So these are the units of what electromagnetic, these are the units of what wavelength. So wavelength is nothing but the distance between two successive, that means side by side crust or raft, is called wavelength. Wavelength is equal to velocity by frequency. Okay, I hope you all understand, right? Clear. Now coming to the next point or next property. The next property is frequency. What is meant by frequency? The number of waves which are passed through a given point on the wave. Here number of waves or number of cycle, complete cycle, or number of vibration, that same terminology only. You can use any word, it is not a matter. The frequency of a wave is the number of complete cycles or vibrations or waves passed through a point in the 1 second. Point on the wave in 1 second is called frequency. Now frequency is equal to velocity by wavelength. Frequency equal to velocity by wavelength. Mu is equal to c by lambda. Mu equal to c by lambda here. Now the formula, this formula used to calculate what, if you know the wavelength and velocity known, it is already fixed value, that is 3 into 10 power 8 meter per second. Okay, if you know the wavelength, then you can able to calculate what frequency here. Clear? Now the units of frequency, very important point. Units of frequency, the units of frequency is equal to what? Cycle per second. Units of frequency, cycle per second, cycle per second, or hertz. And one more important point regarding this, hertz is the SI unit of a frequency. Hertz is the SI unit of a frequency. They'll ask question like that, what is the SI unit of frequency? SI unit of frequency is nothing but hertz. 1 hertz is equal to 1 cycle per second. 1 cycle per second, or simply second inverse. Cycle per second or second inverse. So these are the units of frequency. Clear? Now coming to the next property, that is wave number. The next property is what? Wave number. Okay, wave number. Simple definition, wave number is a reciprocal of wavelength. Wave number is what? Reciprocal of wavelength. So wave number wave number is equal to 1 by wavelength. Nu bar, it is denoted by nu bar. Nu bar is equal to 1 by lambda. Units of wavelength. Units of wavelength, centimeter inverse or meter inverse. That's fine. If wavelength increases, wave number decreases. Okay, na? Now see the first wave on the diagram. See that it has large wavelength, so that less number of waves are here. 1, 2, 3 present in the unit length. If wavelength is very short, then the number of waves increased 1, 2, 3, 4, 5, so on. So that wavelength and wave number is inversely proportional. If wavelength increases, wave number decreases. Wave number nu bar decreases with respect to increase in wavelength lambda. I hope you all understand, right? This is now the last and final one, velocity. You know, velocity means the distance travel by wave, travel by a wave per 1 second, per second. The distance traveled by wave per second is called velocity. The distance traveled by wave per second. Right? Velocity, any wave, electromagnetic radiation that travel with what? Velocity of light. This is C is equal to 3 into 10 power 8 meter per second. Thank you.